So for number 1, we have 8 red balls and 4 blue balls, so 12 total, right? And they want the probability of selecting 4 red balls. So our probability is the number of outcomes that we want out of the total number of outcomes possible. So what we want is we have 8 balls and red balls, and we want to choose 4 of them. So this is the number of ways to choose 4 red balls if we have 8. So 8 red balls, choose 4. So 8 choose 4, number of ways to choose the red balls. And then to make that a probability, we divide that by the total number of ways that we could choose 4 balls. So in total we have 12 balls, and we're choosing 4 of those. So number of ways to choose red, number of ways to choose total, and here they don't ask us to actually solve it, they just have the setup and that's all they want. So that's it for number 1. And 5, we're doing the same thing. Five, they have a dog breeder, has 15 puppies, 8 are which are yellow. And so we have 8 yellow and 15 total. So they want the probability of getting yellow, and they're choosing 5 puppies. So if we're choosing 5 puppies, we have 8 yellow and we want to choose 5 of them. So 8 choose 5 ways to choose your yellow puppies. So you have 8 yellow puppies, you want to choose 5 out of 15 puppies total, and you're choosing 5 of them. So that's it for that. Okay, and for 9, I think we're doing the same thing, except we're going to actually finish solving. So 9, they have 4 red balls and 5 green balls. 4 red, 5 green, so 9 total. And you want to select 3. So they want 3 golden balls, so we're choosing 3. And they want to know the probability of getting 3 green balls. So you have 5 green and you want to choose 3 of them. And then out of 9 total, you want to choose 3 of them. So this many ways to choose the greens, this many ways possible choosing balls total. So 5 choose 3 for green, 9 choose 3 for total. And then they just solve each one of these. You can do them on maybe your calculator does them, 5C3. Otherwise we come down here and use our formula that NCR is n factorial over n minus r factorial times r factorial. So remember, this is 5 factorial over 2 factorial times an extra 3 factorial. So 5 times 4, I'm going to stop it at the 3 factorial to cancel out with this 3 factorial down here. But I also have the 2 factorial. So if I cancel, the 3's cancel, divide by 2, divide by 2, so we get 10. I'll do the same thing for the bottom. I'll do 9C3. So plugging it into the formula, I'll have 9 factorial over 6 factorial times 3 factorial. So 9 times 8 times 7, stop it at the 6. Then 3 times 2 times 1. Cancel out the 6 factorials. Divide by 3 to get a 1. Divide by 3 to get 3. Divide by 2 to get 4. Divide by 2 to get 1. So 3 times 4 times 7, 12 times 7 is 84. So now, putting that back in, the top is 10, bottom is 84. Simplifying that, 5 over 42. And that looks good. So for 13, each of the digits 0 through 9 is written on a slip of paper, and the slips are placed into a hat. If 3 slips of paper are selected at random, determine the probability that the 3 numbers are greater than 4. Alright, so how many numbers are greater? If we have the digits 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These numbers are all greater than 4, right? So we have 1, 2, 3, 4, 5 numbers greater than 4, and we have 10 numbers total. And we're choosing 3. So our probability, there are 5 numbers greater than 4, and we want to choose 3 of them. So 5 choose 3 ways to do what we want. And then to make it a probability, there are 10 numbers total, and we want to choose 3 of those. So 5 choose 3 ways to choose things that are greater than 4, 10 choose 3 ways to choose things total. Finding each one of these, this is 5C3, so 5 factorial over 2 factorial times 3 factorial. So 5 times 4, I'll stop it at the 3 factorial to cancel out with that down there. Divide by 2, I get 10. And then 10C3 will have 10 factorial over 7 factorial times 3 factorial. So 10 times 9 times 8. 7 factorials will cancel. Even with the 3 times 2 times 1. Divide by 3. Divide by 2. So 10 times 3 times 4 is 120. So putting this back in, I have 10 over 120, so 1 out of 12. And that should be good. Check. Yeah, looking good. So for 17, a lottery consists of 46 numbers. You select 6 numbers, and if they match the 6 numbers selected by the Lottery Commission, you win the grand prize. Determine the net probability of winning the grand prize. So there are like the total number of outcomes for this one. You've got 46 numbers, and you want to choose 6 of them. And that's the total number of lottery tickets that are possible. So to win, you just want the one combination that matches. So there's just one combination that matches. I guess you could also look at it as there are 6 winning numbers and you want to choose all 6 of them. And if you did that, this would actually give you 1. Yeah, okay, so 6 winning numbers, you want to choose all 6 of them. Out of 46 numbers possible, and you want to choose 6 of those. So I guess it does work the way we've been doing it. And if we do this 6C6 down here, that would be 6 factorial, 6 minus 6 is 0 factorial, times an extra 6 factorial. And 0 factorial is actually defined as 1, so if you come across this, 0 factorial equals 1. So this is 6 factorial over 1 times 6 factorial. And the 6 factorials cancel, leaving you just a 1 on the top and a 1 on the bottom, so it equals 1, just like we suspected in the beginning. And then we'll crank out this one, 46C6. So that's 46 factorial over 40 factorial times an extra 6 factorial. So 46 times 45 times 44 times 43 times 42 times 41, and we'll let the 40 factorials cancel. And I have 6 times 5 times 4 times 3 times 2 times 1. Those cancel. Let's see, I'll divide by 6 to make that a 7. I'll divide by 5 to make that a 9. I'll divide by 4 to make that an 11. I'll divide by 3 to make the 9 a 3. And I'll divide by 2 to make this a 23. So all that I have left is 23 times 3 times 11 times 43 times 7 times 41. Youch. And I get 9366819. So it should be 1 over 9366819. And we check it. Yep, we match. Excellent.